All right, thinking about back to that last chapter with some probability there. We had the fundamental counting principles. So if there were m ways for an event to occur and n ways for a second event to occur, all we did was take m times n to give us the total number of outcomes possible. So in this example, if you had 5 shirts, 6 pants, and 3 pairs of shoes, how many different outfits could you have? Remember, we could think of this as a tree diagram. There's my 5 shirts. Off of those, I have my 6 pants and then 3 pairs of shoes. But we realized that if we've got 5 pairs of shirts, 6 pairs of pants, and 3 pairs of shoes, just multiply all those together to get the 90 outfits. Then the union of sets is written as set A union set B, so U for union. That's going to be all of the elements in set A or in set B. But when we talk about the intersection of set A and B, this is all the elements in set A and set B. This is the overlap. This is what they have in common. A subset is just a smaller set. It's a part of a larger set. It contains some, but not all, of the elements of the larger set. And the null set is a set with no elements in it. You can represent it as those empty brackets or that symbol there, a 0 with a slash through it. So if here's my set A with the first several letters of the alphabet and set B with the vowels, when we take the union, we are combining those two sets into one. Has to be in set A or set B. Remember that we use those squiggly brackets. When it's A and the intersection of B, it has to be an A and B at once, so just A and E. If I want a subset of B, I could have a bunch of different examples. I could just take A and O. As long as I have some of the elements of B in there, but not all of them, that would be a subset. Permutation, this is the arrangement of objects in a certain order. Order matters. In a permutation where all n elements are used, we use n factorial. That's a special button on our calculator. So how many ways can a club elect a keeper of the points and a treasurer? This is a permutation because you are assigning roles. So let's say that they had 18 men in this club. So when I elect my keeper of the points, I have 18 people to choose from. But once I choose somebody as the keeper of the points, there's only 17 left for the treasurer. Multiplying those numbers together gives me 306 different ways. How many words can we make from the letters of Wisconsin? Remember, we add up, see that there's 9 letters, so 9 factorial on the top. On the bottom, we have 2 I's, 2 S's, 2 N's. Careful when we type that into our calculator. Put the bottom into parentheses, end up with 45,360 words. Combination is just the opposite of a permutation, so you're selecting objects where the order does not matter. You're just taking things as a group. So out of a sock drawer filled with 20 pairs of socks, how many different groups of 3 socks can be selected? So out of those 20, you have to choose 3 of them. The order doesn't matter. Let's say they're all just being thrown in a suitcase for a vacation. Type in that special button under your calculator. Remember NCR. End up with 1,140 different sock groups. Theoretical probability is what should happen in theory. If I was flipping a coin, 50% of the time I should get heads, 50% of the time I should get tails. But experimental probability is what actually happens. So if I flip a coin 10 times, maybe 6 out of the 10 times I got heads, 4 out of the 10 times I got tails. Not exact as the theoretical probability. Conditional probability is one event where something already happened. This reduces the sample space. These are problems with givens. So the card is a heart given that an ace is drawn. That given tells me the denominator. There are only 4 aces in a deck of cards. Out of those 4 aces, there's only 1 ace of hearts. Compound events just mean more than one event happens. And on the back side of your notes there, we have independent events. The outcome of one event does not depend on the outcome of the other. That would be like spinning a spinner and then going to grab a Scrabble tile. They have no effects on each other. Dependent event. One event does depend on the outcome of the other event, just like it does in this example. So if there are 5 blue marbles and 6 green marbles in a bag, that gives me 11 total marbles. If I want to select 2 green marbles, the first green marble that I reach in to grab, there's 6 of them. And if I don't replace that, if I keep that green marble in my hand, now there's only 5 green marbles left in the bag, and there's only 10 total marbles left in the bag. When I multiply those fractions straight across, 30 over 110, and that reduces to 3/11.